Hello class, welcome to our lesson dealing with section 7.4, which deals with quadrilaterals. Before we get into the topic of quadrilaterals, I just want to review a few things about simplifying expressions and about the order of operations when doing so. For the first question, you can't combine any like terms until you get rid of this 4 in front of this quantity of 9x minus 3. You got to make sure you distribute the 4 into both groups, so 4 times 9x would be plus 36x, and then 4 times a minus 3 would be a minus 12. And then combine like terms, 3 plus 36 for the x's would be 39x. Now don't forget, it's not 12 plus 3, it's negative 12, because remember, minus 12 is the same as adding a negative if you do keep change. So negative 12 plus 3 would be a negative 9, not a negative 15. So that's something to keep track of on the first one. In the second one, the common mistake is students try to take 18 minus 5 first. Okay, remember the order of operations, so you have to multiply before you add or subtract. So you need to take the negative 5, not 5, negative 5, because plus negative 5 would be the same as subtracting 5. So negative 5 times 2x is negative 10x, or minus 10x here. And then negative 5 times a negative 4 would be a positive 20. When I combine like terms, I can only combine the constants together. So I leave negative 10x as is. And then 18 plus the 20 would be 38. I could have switched the order of that, made it 38 minus 10x. So that's another way that you could look at that situation in order to get your answer. Okay, quadrilaterals. Quadrilateral is a four-sided object, so the word quad is four, and then lateral would be side. So it's a polygon, so polygons have vertices and have straight edges kind of going in between those vertices. So all four of these are examples of quadrilaterals, and then we'll go through what those types of quadrilaterals are depending on their properties that are given to you. Okay, so here's the chart with all the properties. This is right from your textbook. There's a lot of words here, a lot of information. You need to know this chart really well. So at the top is quadrilateral. So any four-sided object is called a quadrilateral. But then you can develop more specific definitions depending on how the question is set up. So let's start on the left side. So we have a trapezoid. So this is the trapezoid that you're used to seeing. Okay, probably one that you've seen in like a tangram situation, like when you were in elementary school. Okay, a trapezoid is a quadrilateral that has one pair of parallel sides, just one. And we represent parallel by these arrows here, kind of showing like they flow in the same direction. So that's what that piece is looking at. Notice that trapezoids are kind of their own group. They're just by themselves, a trapezoid, exactly one pair of parallel sides. If we go to the far right side, there's also what's known as a kite. The kite is also in its own category. It's a quadrilateral where it has two pairs of congruent adjacent sides. Okay, now that's a lot of info here. Here's what it's saying. There's two sides that meet at a vertex. Those two sides are the same or congruent. Then the other two meet at the other vertex on the opposite side. Those two sides are congruent. But all four of them aren't going to be the same, or the ones opposite of each other aren't the same. So it's basically saying like these two are the same and these two are the same, but not the ones kind of opposite of each other. Okay, so trapezoid and kite are their own categories. But then inside another category is what's known as a parallelogram. A parallelogram is by definition opposite sides are parallel and congruent, both sets. So you'll notice that parallel is the arrow. So notice these two have one arrow and one tick mark to show that they're congruent. Then the other have two tick marks to show they're congruent and two arrows to show that that's another set of parallel sides. So parallelograms then branch out into their own categories as well. There's what's known as the rectangle, which is basically a parallelogram. So it has all the pieces of a parallelogram. Opposite sides are parallel, opposite sides are congruent, but it also has four right angles. Okay, so rectangle is probably the one you've seen the most besides a square. Okay, so rectangle, okay, fits all the definition of a parallelogram, but it also has four right angles. A rhombus fits the definition of a parallelogram. Opposite sides are parallel, opposite sides are congruent, but for a rhombus, all four sides are congruent. Now, here's where it's important to recognize the kite versus the rhombus. The rhombus has all four congruent, which is not representing a kite because a kite says the opposite side lengths can't be the same. Finally, we have what at the bottom is the square, which is the one we learned kind of first off with a rectangle. Now, a square has the properties of a parallelogram, has the properties of a rectangle, and the properties of a rhombus all at the same time, which essentially means opposite sides are parallel, opposite sides are congruent, four right angles, and all four side lengths are the same or congruent side measures. So when we're looking at this, okay, you have this flow chart, kind of as you're going through, but you want to make sure that you realize the most specific answer is the one we want. So here's what we don't want to say. If I say, all right, explain to me what shape this one is right here, and it's a rhombus. Don't say, oh, it's just quadrilateral, and name them all quadrilaterals. Okay, we want the most specific version that we can use to help find the answer. Okay, so classifying, it's just a matter of recognizing what you're looking at. All four sides are the same, that would be a rhombus. But all four angles are also 90, so that would be a square then, more specifically compared to the rhombus. This one here is a version of a kite because these two have the same side length. They're congruent, and the other two are. But notice the congruent pieces are adjacent, not opposite. So that would be classified as a kite. This one here, 4 side lengths that are equal in measure. Now, they don't show that they're parallel, but it's kind of a geometry a proof and kind of properties that this is going to be a version of a parallelogram. But if all 4 sides are equal, rhombus. Notice opposite sides are congruent, but 4 right angles, that would be a rectangle. And a trapezoid. Now, here's what's important about the trapezoid. A trapezoid does not have to have these 2 sides be the same. This is what's known as an isosceles trapezoid because the 2 sides that aren't the parallel sides, they are the same distance or congruent in measure, okay, or equal in measure. But the 2 sides that are parallel make it the trapezoid, not these 2. Okay, so that's something that you want to think about when it comes to the trapezoid. Okay, the other thing you might have to do is just look at the definition and draw something. So if you have exactly 1 pair of parallel sides, that would be a trapezoid. 4 congruent sides, but it's not a square, that's a rhombus because you have 4 congruent side lengths as you're looking at that situation. The next one is 4 congruent sides and 4 right angles. Well, if all the sides are the same and all the angles are right angles, that would be a square. Compare that with the one on the right. 4 right angles, that's not a square, that would be a rectangle because you're saying that the side lengths don't all have to be the same. One thing you may want to add into the second picture is the 2 tick marks for 2 of the sides and 1 tick mark for the other to prove that they are congruent opposite sides. The next one says 2 pairs of congruent adjacent sides and opposite sides aren't congruent. That's the weird one. That's the kite. So these 2 are the same and these 2 are the same, but the ones opposite are not the same. Congruent and parallel opposite sides, it's not a rectangle. So that could just be a base case of a parallelogram. So the opposite sides are parallel and congruent, but it doesn't have right angles, so that could be a parallelogram then at that point. On your homework, you have questions 1 through 9. Now, 1 through 9 have some definitions. Remember to look back in the book a little bit, a few pages to find those definitions. That chart that was in this in the slides is also in your textbook, so you could look at that as a reference. Make sure you're using the most specific version to be able to answer the question of what type of quadrilateral is it. On 27 through 29, those are some review questions from some different sections in the book. Number 30, though, is percent of change. Now, we did percent of change in Chapter 6. It says what section it's in. Remember, percent of change is that new minus original divided by the original idea to figure out how much change there was, then divide by the original. But if you're not sure how to do that, it says what section it's on at the end, and you want to make sure you show work about where that answer came from. Have a good day, everyone.